Hello everybody. This organic chemistry video provides a basic introduction into functional groups. It covers alkanes, alkenes, alkynes, aromatic rings, alcohols, esters, carboxylic acids, ketones, and aldehydes. Starting with alkanes. Let's take this particular molecule. This molecule is called pentane because it contains 5 carbon atoms. You have to use different prefixes starting from methane, ethane, propane, and so on. This is a straight chain alkane because it does not contain or it does not have alkyl groups or substituents. Let's see a one with the substituents or with alkyl groups. This one, let's name this particular molecule. To name this molecule, you have to follow these rules. The first rule is to find the longest continuous chain of carbon atoms. Here in this molecule, I can see this is the longest continuous chain, which is called the parent chain. The parent chain here contains 8 carbon atoms, so its name is octane. Let's circle and name the alkyl groups we have here. This one is called methyl. This one is called isobutyl. This is ethyl. If you are not familiar with the alkyl groups or the substituents, I have here in this PowerPoint a table contains different alkyl groups starting from methyl until tertiary butyl. So you have to know these alkyl groups to name branch chain alkanes. Let's go back to this molecule and give it a finalized name. Before you give it a name, you have to number it in a correct way. Correct numbering of parent chain is very important. You have to start from the end that is closest to the branching. So here, if I start over here, 1, 2, so the first branch will be on carbon number 2. So this is the correct numbering to start from here. 1, 2, 3, 4. So methyl is on carbon number 2, isobutyl on carbon number 4, and ethyl is on carbon number 5. So the final name will be 5-ethyl, 4-isobutyl, 2-methyl, octane. We place the name of parent chain at the end of the name. Let's talk about the second functional group is alkene. Alkene contains at least one double bond, carbon-carbon double bond. So let's see this particular molecule. The name of this molecule is 2-butene. I use suffix ene because this molecule it contains at least one double bond, and number 2 indicates that the double bond is between carbon number 2 and 3. So you start number the chain, hydrocarbon chain, from the nearest double bond. Here the priority is for the double bond. Double bond should take the lowest number, not the alkyl group. So if you have this molecule you start numbering it from left to right, not from right to left. Why? Because the priority here for the double bond, not for the alkyl group. So the name of this compound is 4-methyl 2-pentene. You have to specify the location of the double bond after you write the alkyl group. Let's go to the third functional group, which is alkyne. Alkyne contains at least one triple bond. Let's see this example. So the name of this hydrocarbon molecule is 2-butene. The triple bond between carbon number 2 and carbon number 3. We can represent this condensed structural formula in a line angle formula like that. This is the first carbon, the second, the third, and the fourth. Let's go to the next functional group, which is called cycloalkanes. Cycloalkanes, actually, it's a cyclic. It forms a ring-like or a circular structure. See this example. This is called a cyclopentane because it contains 5 carbon atoms. 1, 2, 3, 4, 5. This one is cyclohexane because it contains 6 carbon atoms. What about if we have a substituents or substituents on the cycloalkane? So let's learn how to name cyclic alkanes. Naming. Cyclic alkanes. Take this example. Try to name it. Here, the cycloalkane is cyclopropane because it contains 3 carbon atoms. There is a methyl group on this cycloalkane, so without putting any number, because it's only one substituent, one alkyl group, the name of this compound is methyl cyclopropane. Let's take second example. Okay, try to name this cycloalkane. Here, as you can see, I have 2 substituents, 2 alkyl groups. The first one is isopropyl, this. This one is methyl. So, where I have to place number 1, on which carbon, on which substituent or alkyl group. So alkyl groups are named in alphabetical order and numbered as well in alphabetical order. Here we have iso, here we have methyl. So I will put number 1 over here, and I'm gonna go clockwise because you have to go in a way that gives the second branch a lowest number. So going this way, 1, 2, 3. So the name of this cycloalkane molecule is 1 isopropyl 3-methyl cyclohexane. Another functional group is called alkyl halide. Alkyl halide is a hydrocarbon chain attached to a halogen element. So, hydrocarbon chain attached to a halogen like chlorine, bromine, fluorine, iodide. Let's take an example. If we have this particular molecule, bromine element is on carbon number 2. So the name of this molecule will be 2-bromopentane. Hydrocarbons are divided into two parts, aliphatic and aromatic compounds. An aliphatic compound is a hydrocarbon compound containing carbon and hydrogen joined together in straight chains, branched chains, or in rings. Aliphatic compounds may be saturated, like alkanes and cycloalkanes, or unsaturated, like alkenes or alkynes. The simplest aliphatic hydrocarbon is methane. Aromatic compounds contain benzene ring. I will talk about it in the coming slide. In this table, we have the general molecular formula of alkane, alkene, and alkyne. General molecular formula is very important to determine the number of hydrogen atoms in a certain molecule. If the number of carbon atoms is given, which is represented with the letter N, small n, I can find the number of hydrogen atoms in this compound. If it is alkane, so I will use this formula CnH2n plus 2. Example, a molecule with 2 carbon atoms takes 6 hydrogen atoms, and so on for alkene and alkyne. Alkene has a formula CnH2n, alkyne has a formula CnH2n minus 2. Let's answer this question. How many carbon and hydrogen atoms in each molecule? In the first molecule, first of all, let's count the number of carbon atoms. In the parent chain, there are 8 carbon atoms. In the first alkyl group containing 2 carbon atoms, in the second alkyl group is containing 1 carbon atom. So the total is 11. So 11 carbon atoms. How many hydrogen atoms should these carbon atoms take? So I will use the formula of alkyne because there is a triple bond here. The formula of alkyne is CnH2n minus 2. So I have to multiply 11 by 2 and subtract 2. So it becomes 20. So this is the molecular formula of the first example. Let's solve the second example. Here in this line angle formula, or a shorthand formula for alkene, there are 6 carbon atoms, so C6, but there is a double bond here, so I will use the formula CnH2n. I'm gonna just multiply the number of carbon atoms by 2, so it becomes C6H12. In the third example, in the parent chain, there are 6 carbons and plus 1 carbon in the methyl group. So the total is C7, and number of hydrogen atoms is 14. Just multiply by 2 because it's an alkene molecule. Benzene ring. Benzene ring is an organic chemical compound with the molecular formula C6H6. The benzene molecule is composed of 6 carbon atoms joined in a ring with 1 hydrogen atom attached to each. Six carbon atoms bonded by alternating single, double bonds. Single, here's the single bond, here's the double bond, single, double. As it contains only carbon and hydrogen atoms, benzene is classified as hydrocarbon. In this slide, I will show you how we can name aromatic compounds, compounds that contain benzene ring. So benzene ring with one substituent is named in a similar way as hydrocarbons, but for sure you have to put the parent name benzene. So the first example, there is a bromine atom on this benzene ring, so the name of this molecule is bromobenzene. The second molecule, there is an ethyl group on this benzene ring, so the name of this molecule is ethyl benzene. The last one, this alkyl group is called isopropyl. So the name, this molecule is called isopropyl benzene. Cycloalkanes with 3 branches or 3 substituents. This molecule is called 1,1,2-trimethylcyclopentane. Why? Why not 1,2,2-trimethylcyclopentane? If you have a cycloalkane with 3 branches, look at the branches here. This is the first alkyl group, methyl, second methyl group, and the third methyl group. If you start numbering from this carbon atom, so the numbers will be 1, 1, 2. If you start numbering from this carbon, the numbers will be like that, 1, 2, 2. Which way gives the lowest possible value? For sure the first one. 1 plus 1 plus 2 is 4, while 1 plus 2 plus 2 is 5. So the rule is choose numbers to get the lowest possible values in this case. If you take the second example, here we have propyl group, methyl and ethyl group. In this example, we have to try which way gives you the lowest possible value. If you start numbering from here, this carbon will be number 1, 2, 3, 4. So the numbers are 1, 2, and 4. The value of these numbers is 7. 4 plus 2 plus 1, 7. If you start numbering from ethyl, 1, 2, 3, 4, so the values are 1, 3, and 4. The value of these numbers is 4 plus 3, 7 plus 1, 8. So the first one is correct, the second and the third are wrong. Cycloalkanes is regarded as a substituent. In this molecule, I have a parent. The parent chain in this molecule is not the cycloalkane, is this chain 1, 2, 3, 4, 5, 6, and 7. Cycloalkanes is regarded as a substituent when the parent chain has 6 or more carbon atoms. Look at here, this chain has more than 6 carbon atoms, so I am going to take this cycloalkane as a substituent, not as a parent. So the correct name for this molecule is, I'm going to number the chain from here. This carbon will be number 1. So it will be 2-cyclopentylheptane. Remember that for any alkyl group, we remove the suffix a and e and we put YL for the substituents only. Why it's pent because this cycloalkane contains 5 carbon atoms. So this molecule is called 2-cyclopentylheptane. If an alkyl chain of the cycloalkane has a greater number of carbons, then use the alkyl chain as the parent and the cycloalkane as a cycloalkyl substituent. Look at this example. Here we have 3 carbon atoms in this cycloalkane, while this chain contains 4 carbon atoms. So I am going to take this one as a parent chain, and this part will be the alkyl group. So this molecule is called 2-cyclopropylbutane. This parent chain contains 4 carbon atoms, so it's a butane, and the alkyl group cyclopropyl is on carbon number 2, so the name is 2-cyclopropylbutane. Isomers. Actually, we have 2 types of isomers: structural isomers and stereoisomers. Structural isomers are compounds that have the same atoms, means same chemical formula, but they are arranged or bonded differently. We are going to focus only on structural isomers. We are not going to talk in this lesson about stereoisomers. If you have 2 isomers molecules, they have they might have different properties. Let's see some examples on structural isomers. Here we have hexane. We have 5 molecules with same number of carbon and hydrogen atoms, but they are arranged, carbon atoms are arranged differently. So hexane and 2-methylpentane, they have the same number of carbon, 6 carbon atoms, but they are arranged differently. This is isomer. The longest chain has to include the double or triple bond. If you have a molecule, alkene or alkyne molecule, and you want to name it, try to choose the chain that contains the double in alkene and the triple in alkyne, even if there is another chain contains more carbon atoms. Let's see this example. This chain this hydrocarbon chain contains 1, 2, 3, 4, 5, 6, 7 carbon atoms, while this chain contains 6 carbon atoms. Which one I have to take? For sure I will take this one, the 6 carbon atoms chain. Why? Because this chain contains the double bond. If you take the chain that does not contain the double bond, the name of the molecule will be wrong. So the first one is wrong and the second is correct. So the correct name for this molecule is, for sure you start numbering the chain from the nearest double bond. Here the priority for the double bond: 1, 2, 3, 4, 6. So on carbon number 2 there is an ethyl group. On carbon number 5 a methyl group. So the name of this molecule is 2-ethyl 5-methyl 1-hexene. 1 is the number, or is the position of the double bond. If the double bond between carbon number 1 and 2, you choose number 1. You mention number 1. If it is between 3 and 4, you mention number 3. Always take the lower number.